Section 10.5 is titled Inverse Trigonometric Functions. So from Chapter 4, recall that for a function to have an inverse function, the function must be 1-to-1. So it must pass the horizontal line test. We must have no y values repeating. So we're talking about if we have a function f of x, then the inverse function looks like f inverse of x. Let me clean that up a little bit. F inverse of x. That's an inverse function. So let's visit or revisit some of our values for sine, cosine, and tangent. And the goal right here with these 6 little questions or 6 little problems is to notice that our trig functions are not 1-to-1 naturally. So the sine of 30, if I put in the sine of 30, I would get a half. If I put in the sine of 150, I would also get a half. You can try both of those on your calculator. Just make sure you check your mode, make sure you're in degree mode. So the input is x. If I put in 30, I get a half for the sine function. And if I put in 150, I get a half for the sine function. So you can see right here, I have repeating y values. When y values repeat, we do not have a 1-to-1 function. Let's take a look at cosine. We know that if I put in 45 degrees, the input for cosine, the cosine of 45 degrees is radical 2 over 2. So putting in 45 degrees for my x value, my y value is radical 2 over 2. If I put in 315 into the cosine function, I'm in quadrant 4. The reference angle is 45 still. I still get radical 2 over 2. So cosine is not 1-to-1. Notice the y repeats. And tangent. The tangent of 60 is the square root of 3. The tangent of 240, also the square root of 3. This has a reference angle of 60, and it's still positive because it's in quadrant 3. So putting in 60 to tangent gives us radical 3. Putting in 240 into tangent gives us radical 3. Again, not 1-to-1. So we have a problem with our functions. They are naturally not 1-to-1. Since they're not 1-to-1, the domain for each of these functions needs to be restricted so that we can consider inverse functions. So we're going to go through each one. We're going to start with what the restricted domain is for the function. So if I have y equals sine of x, we already saw up above that naturally is not 1-to-1. If I restricted those so that I can get some negatives and some positives, and I use quadrant 1, all those sine values are negative, and quadrant 4, all these sine values are, in quadrant 1, they're all positive. In quadrant 4, they're all negative. I think I just misspoke. So we're going to use negative 90 to 90 for our restricted domain. Negative 90 degrees up to 90 degrees. So I've shaded that here. We're going to use that section of sine around the unit circle for our inverse function. So our inverse functions look like y equals sine inverse of x, or y equals arc sine of x. They mean the same thing. If we have sine inverse or arc sine, you're basically just pressing second sine on your calculator. You really already know that. Since it's an inverse, the domain from the original becomes the range for the inverse. can think of that like, it's going to be the answers. Negative 90 to 90 is going to become the answers if I'm doing an inverse function. So you know what to press. It's just second sine of 1/2. Now I'd like you to be in degree mode. My answers will be in degrees. So check your modes. So literally you're just going to hit second sine. You should really already know that when you see sine inverse. Second sine of 1/2, and we get 30 degrees. Don't forget your degree symbol anymore. We're in radians and degrees, so you have to be explicit. Sine inverse of -1. So hit second sine, -1, and you get -90 degrees. Arc sine, again, really means the same thing. So arc sine, you're still going to hit second sine of -1/2. So now we'd be down in here, -1/2. So our angle is -30 degrees. Try arc sine of -0.3286. Go to my calculator here. Check my mode. Okay. So second sine -0.3286. And we have -19.18 degrees. Let's also practice our DMS. Let's get that in degrees and minutes. So to the nearest minute, -19 degrees, 11 minutes. All right. And try the last one. Arc sine of 0.8. Second sine of 0.8. Do your DMS as well. I'll wait a moment. You should have 53 degrees, 8 minutes. All right, so what we see here is that what we're used to putting in the angle to our sine function and getting out an answer. So the sine of 30 is 1/2. So if the sine of 30 is 1/2, then the sine inverse of 1/2 is 30 degrees. So in the regular function, the input is the angle. In the inverse function, the result is the angle. In the original function, the result is your value. In your inverse function, the result, or the 1/2 value, is your input. So they just flip-flop. Let me circle that. Let's try cosine. So we need positives and negatives, and this time, if I use quadrant 1 and quadrant 4, remember, cosine's positive in both of those, so we don't use quadrant 4. What we use here is quadrant 1 all the way through to quadrant 2. So we're going to restrict this to this section, 0 to 180. So go ahead and shade that. So we're taking cosine of x, and we are restricting its domain so that we can consider an inverse. These values will become the answers. So I'm going to write the same thing I did on the sine. This becomes the range of cosinverse. Range are your y values coming out. So our inverse cosine functions look like cosine inverse of x, or arc cos of x. Okay, we're just hitting here. Second cosine on our calculators. That will give us cos inverse of whatever you put in. Let's give these a run here. Cos inverse of 0.5. Second, cos of 0.5. Of course, is 60 degrees. That's a chart value, so we know it's in the chart. All right. Second cos of 0. Where is cosine 0 in this arc of values? And indeed, it is 90 degrees right at the top. Remember where we have cosine sine. That's the 0.01 on the unit circles. Cosine of 90 is 0, so arc cos of 0 is 90. Arc cos of negative square root of 3 over 2. We now know we're going to be in quadrant 2 over here because it's negative. Okay, so our angle will be obtuse. Go ahead and type that in. Second cos, negative square root of 3 over 2. 150 degrees. And the last one, second cos of 0.8. Let's get this in DMS. Second apps, DMS. 36 degrees, 52 minutes. Alrighty. And the last function we're going to look at today is the tangent function. So what should we restrict the tangent function to? So that we have 1-to-1, no values repeating, and so that we have the positives and the negatives. And what we'll use here is negative 90 to 90. Now the reason we use down into quadrant 4 and up through quadrant 1 is because at 90, tangent is undefined. So it actually, we don't get a value there, and we don't get a value down here at negative 90 either. So we just want to write less thans here. Don't forget your degree symbols. I might have forgotten a couple. I want to be careful there. All right, and remember those values will become, this domain will become this range. Remember, for inverse functions, your x's and your y's flip-flop. So you're seeing a lot of this backwards. That x becomes the y, and that y becomes the x. So we have y equals tan inverse of x. That's what the inverse function looks like. Or arctan of x. And you know, you're just going to hit second tan on your calculator to get your inverse function. So second tan of 0 is 0 degrees. Go ahead and do the rest of those. I'll just pause for a moment while you finish up those 3. Second tan. Second tan of radical 3, 60 degrees. Second tan of negative 1, we know we're down here. Negative 45 degrees. And second tan of 4.5. DMS it. Get it to the nearest minute. I have 77 degrees, 28 minutes. All right, almost done. Nice short lesson. So these can look, these types of questions can look, appear in various ways. That's what I'm trying to say. Now let's consider if they double up some trig functions. So here I have sine of arc cos of 1/2. So this, really remember, is an angle. So I'm really doing the sine of some angle, just like normal. So first let's figure out what that angle is. Arc cos of 1/2, that's definitely a chart value, 1/2. And it's positive, so we know we're in quadrant 1 for arc cos. Arc cos of 1/2 is, or second cos of 1/2, 60 degrees. And then the sine of 60 degrees from the chart is radical 3 over 2. Number 2, we're doing the tan. This is an angle. Arc sine of negative radical 2 over 2 is an angle. So first figure out the angle. It's negative for sine, arc sine, so I know I'm going down into quadrant 4. A negative angle, and that is negative 45 degrees, and the tan of negative 45 degrees is negative 1. All right, on the other side, number 3 and number 4. It says find the exact angle, or find an exact angle. I think I'm going to change that too. That satisfies the equation. So all along, we've actually been taking these, and when we need theta, we've been doing sine inverse on the left, because it gets rid of the sine in terms, and sine inverse on the right. We have negative square root of 3 over 2. So truly, we've already done these. Sine inverse, sine inverse. So then when we do sine inverse of negative square root of 3 over 2, your calculator tells you that that is negative 60 degrees. Now, we're looking at these today. I'm just going to talk a little bit here. You have to watch out for this type of question. Sometimes the directions here will ask you to find all values, and we've done these before, find all values for theta between 0 and 360. If those are the directions, then this is not the answer that they're looking for, because this is a negative angle. If they ask us to use this set of values, 0 to 360, then they're typically looking for the two quadrants where sine is negative, which would be quadrant 3 and quadrant 4, and get the reference angle, which would be 60, and then give answers in quadrant 3 and quadrant 4. So 60 in quadrant 3 would be 240 degrees, and in quadrant 4 it would be 300 degrees. So just as a side note, and we've done these already, sometimes the directions are slightly different. You just want to know how to play the problem, and which solution are they looking for? Are they asking you to do an inverse trig function, or are they asking you to find all values for theta between 0 and 360? So just watch out for that. All right, last one. Secant of theta equals radical 2. So I know if I'm going to be doing an inverse function that I really can't do sec inverse on my calculator, so I'm going to need to do cosine theta. So if secant theta is radical 2, then cosine theta is 1 over radical 2, which is radical 2 over 2 when we rationalize. So let's rewrite this problem as cos theta is radical 2 over 2. You see it's positive, so we know we're in quadrant 1. Do a cos inverse on both sides. And you've got theta theta equals cos inverse radical 2 over 2. Definitely a chart value. You can also use your calculator in degrees. That is 45 degrees. All right. See you tomorrow.